Yeah. So today's topic is about steel structures, that is design of steel structures. In that, first is truss design. Next is other types of trusses also you can design, and other types of steel structures like warehouses and industrial pre-engineered buildings and other buildings also you can design in this STAAD software. So I am going to start with the truss model. So here I am creating one. Why are you unmuting yourself? Don't mute, don't talk something in between. So this is the truss that I'm going to model now. This is the truss model. Yeah, this is the truss model. The height of the truss is 4 meters, and this width I'm going to take as 8 meters, and this inclination I'm going to take as 8 degrees. Okay, 8 degrees is the inclination. So if it is 8 degrees, what will be the central height? Can anyone say? If it is 8 degrees, what is the central height? Okay, this I am rotating with 8 degrees. So what will be the angle if I rotate this? Let me check with the angle whether I got right or wrong. Yeah, 8 degrees is showing. So what is the length from here to here? So it is 562.25 mm. So it is 0.56 meters. 0.56 meters is the height. So what I'm going to do is that I'll go to the staad model. So this height, in the text, you can write this height as 0.56 meters. Right. So this is going to be the height. Right, and remaining are the lengths over here. This is 8 meters. This is 4 meters. This is the central portion is 0.56, and the in between these are the truss members. In between these are the truss members. These are all the truss members. Okay. So now let us go to the staad. Are you following or not?
Yes, sir.
Yes, sir.
This is a pin connection over here, and this is a pin connection over here, right? So this model will do it in the staad Pro. I'll go to the new file, and I'm going to select the truss. Since it is a truss model, I'm going to select the truss model, and I'm going to go to folder where go to this folder, truss. Some file name I have kept, and I'm using meters and kilonewtons, and click on next, and then go to the add beam option and click on finish. Now you can go to the geometry part and give coordinates 0, 0, 0, and in x direction the total length is 8 meters. So I've given 8 meters, and the vertical part is how much? 0, and y direction it is 4 meters, and 8 and 4 meters. Yeah, 8 and 4 meters. So this is my truss shape. The nodes that I have to create. Then I'm going to create the add beam option. Then I'm going to create this in between member, and from this in between member you can select the member and insert node at the center by simply right clicking over here and going to add at midpoint. Click on add at midpoint and say OK. So exactly at that midpoint the node will be added. So you can select this node and go to the transitional repeat, and in the y direction what is the distance? 0.56. 0.56 meters is the height in the vertical direction. Click on link step and say OK. So this is the height. So from here you can use two, you can join these two members to complete the shape. So this is the shape, and in between we are having some members. For that, first you need to divide this beam into 3 components. So go to the geometry and you can say split beam option. You can use this split beam option. Are you following?
Sir.
So
Yes, sir.
go
Yes,
to
sir.
geometry, split beam option, and here how many numbers you want to split?
Three.
Three numbers. If you want to split it into three numbers, then you have to give here number over there. Here you see that there is a n over here, n equals to 2. That means it will split into 2. So I'm going to give 3 over here, 3, and click on this add n points. So like this, it is going to split 3 numbers. Okay, and if you say okay, you will get 3 nodes over here. Similarly, the same procedure for the remaining members also. Select all the members, right click on the mouse, click on insert node, and you can click over here, add n node points and give 3 over here. Understood? And then click on OK. Once you click on OK, you will get the node 3. It's going to split into 3. Each beam will be split into 3 members. So if you give the midpoint option, then only it is going to split into 2 numbers. So I'm going to click on OK and assign the nodes like this. Okay. Then you can give add beam option command. You can use add beam option command and add the members. So I'm going to go to the add beam option, select first and the second, and then like this, and then from here to here, here to here, and here to here, and here to here, here to here, here to here, here to here, and here to here. So this is my truss model. Right? So here you can see that we have created the nodes like this and completed the model. This is your truss model. So for this truss model, you will have to, if I go to the whiteboard screen, and this is the plan, like this is the plan where the trusses should be placed. So this is a total area of, let me take this one as, I told you 8 meters is this, and I'm going to take this one as 16 meters. So this is the total area it should cover. So total 8 by 16. And here we have to model the truss. These are the trusses. At every 4 meters, I'm going to develop one truss like this. This will be 4, this will be 4, this will be 4, and this will be 4. So total altogether will be 16 meters. So total how many trusses? 1, 2, 3, 4, and 5. So total 5 trusses should be modeled at a distance of 4 meters. So what I'll do, I'm going to select the entire truss, go to the 3D view option for the better view, and then go to translational repeat, and in which direction you want to project those, you have to select the direction alongside
Yeah,
direction,
direction, sir.
and you have to give 4 meters of here because the bay width is 4 meters, and number of trusses is 4 trusses. Already one is there which is model, so additional 4 trusses will be created. You can then click on OK. If you click on link steps, all the members will be linked. But if you don't want to link the steps, you can just say OK. So like this, the trusses will be created. These trusses should be connected by the beams at the ends of here along this length, along this length, along this length, and at this center, and also this in between also you have to uh, right create the beams. So what I'm going to do is that now select the nodes over there, and you can use you can go to the nodes option. You can go in this manner, you can select these nodes and these nodes, and also at the top I'm selecting all the nodes. Okay, and then after selecting these nodes, you can go to the geometry and click on connect beams along Z direction. Total 36 members are created. Just click on OK, and the beams will be created. These are called as purlins. These beams are called as
Berlin.
purlins. Purlins. Okay, so these beams are called as purlins, and on these purlins you will be having the roof sheet material అంటే మనం స్టీల్ మెటీరియల్స్ ఉంటాయి కదా అవి కవర్ చేయడం. దిస్ ఇస్ అ రూఫ్ truss, roof shed, like for especially in the parking zones and where you want the temporary structures, industrial temporary structures, you can construct these kind of sheds. Okay, this is my model. So the geometry part is over. Next, you can go to the general option. I think you know the steps after geometry, what to go to the general option,
Properties.
give the properties, supports, and other items. So go to
Application.
general, go to the fixed support first. First, go to the supports and create a support, and create a pin support. Since it is a steel and it is a truss, we are going to take it as a pin connection. Click on add, select the pin connection, and select all the nodes. You can select all the bottom nodes. Okay, this node, and this node, and simply go to the assign and assign. So this is your truss model. And from here, you can go to the properties option. Since it is a steel building, so you have to give all the steel members. Since it is a steel building, you have to give all the steel members. Right. So here in the properties option, you have section database option available. So for RCC, you have to go to the defined option, which is there on the right side. And for steel building, it is section database. This is the option, right? This is the option, section database. So once if you click on this section database, you click on this section database, you will get this window, this screen you're going to get. And in this screen, you have all the countries like American standard steel sections are there. Then Australian standard, Brazil, British, Canadian, Chinese, Dutch, European, French, German, Indian, Japanese, and all other different countries steel sections will be there. So everywhere steel will not be same throughout the world. The steel sections will not be same. As per Indians, we have our own steel section sizes. So we have our database, that is the steel section database. So click on Indian steel sections. If you click on Indian steel sections, so these are the section shapes that we are having. Oh yeah, these are the different shapes that we have. Generally, what are the steel sections we have? Generally, steel section Saint and do you remember? Do you have? Do you know the steel tables book? Do you know that there is a steel tables book? Steel tables book తెలుసా?
No, sir.
Steel tables book. So in steel tables book, which is IS Indian standards. The Indian standards will be there in steel tables book as per the Indian government they have released. And that you will be having angle section, second I section, third T section, fourth panel section, that is C section, fifth pipe sections, and etc. So there are many built-up sections also will be there, many types. So these are the general standard sections that are there. So angle section means it is going to be like an angle. It is going to, if I draw the angle section, it is going to be like this shape. Then if I talk about the I section, I think you know I section is this shape. Then if I talk about the T section, so it is similar to the I section, but you don't have the bottom flange. This is my I section. Then channel section. Channel section is something, it's going to be like this, like a she shape. Like this is going to be the channel section. Then pipe section, I think you know the pipe section. It is a circular section with a hole over here. So all sections will be there, right? So these are the sections that are standardly developed and which are widely used in India, right? So I'm going to show you in the browser also. I'm going to show you some standard sections. So here you have the handbook there, and we'll see the images. Here you have, these are the shapes: angle section, T section, channel section, I section, and beams and hollow rectangular sections and circular hollow section. So angle sections like this, they are going to be manufactured like this. You can see this diagram, and you can see this diagram. So like this, it will be manufactured. These are all the angle sections. If you see the I sections like this, they will be manufactured. You can see that over here. This is the I section. సో మీకు ట్రైన్ ట్రాక్స్ ఉంటాయి కదా చూసారా, ట్రాక్స్ లో కూడా ఈ ఐ సెక్షన్స్ యూజ్ చేస్తారు.
Yes, sir.
So this one, like this, it is going to be there. On this track only the train wheels will be fixed and they will run through this one. Then you have channel sections like this. This is the she-shaped channel section, real section that has been modeled. Okay. So this is my channel section. Then you have circular hollow section. Circular hollow section. So these are popularly called as pipes. These are the pipes that will be uh, manufactured. So these also have the standard thicknesses and standard diameters that are there that will be modeled. Okay, concrete అంటే మనం ఎలా కావాలంటే we can mold into whatever shape that we want, but for this kind of sections it is not possible, right? For steel it is not possible, for concrete it is possible. That's why Indian sections there will be some standard sections, and those sections only we can use. We cannot create a new angle section of our size.
You can just say 20 minutes, huh?
Yes, who's speaking? Right, so these are the section sizes that are there, and we can model this one. So we'll use all these sections in our stat pro. We'll see where they are, and we are going to design them. Close. So here we go to the Indian sections, and you can select, go to the angle section. I'm going to the angle section, and I'm going to select some angle sections of 90 by 90 by 8, 90 by 90 by 10, or I can select still lesser size also. If you want, you can select 90 by 90 by 10 is enough. I will to add 90 by 90 by 10. Then I'm going to add some pipe sections. I'm going to take 212, 219 diameter medium, and 193 diameter medium, then 89 medium, and some other I shape, that is ISHB, ISMB 125. I'll take ISMB 125 and I'll click on close. So I am going to use ISHB 125. Remove this one. Sections and channel sections. 90 degrees is the angle section, and I'm going to give this 90 degrees to this. No, 90 degrees. I'm going to give pipe section. Mostly I use pipe sections because the recent times most of the structures they are using pipes only because it has many other advantages. I'm going to use this truss members as pipe section 180 988.9. I'm going to assign this. Then for the beam, I'm going to select IS MB 125. Like this, and I'm going to assign it here. Then for the incline members also, I'm selecting this IS MB 125 and clicking on that. So any sections you can give, I'm just giving it. So no need to think that these sections only you can give, but any sections you can select. So I'm selecting these two members. I'm going to use pipe section for this and click on assign. And the central post, I'm going to give it as ISMB 125. And this is for the purlins, I'm going to give 193 as purlins. And click on assign. Right. So this is how I'm going to give the properties. Then after properties, what is the next step? What is the next step?
Supports apply and applying of loads next.
Application of loads, right?
Loads.
So what are the loads that are going to come onto the truss?
अरे ऑन है तो
Axial loads.
So there are many on trusses. You will be having the sheet load, dead load, and you will be having other loads also. So what are the loads that you are going to get in dead load? First one is sheeting. Second one is what? Self weight. The first one will be self weight. Self weight. Then second one is roof sheeting. Think of that. Roof sheeting. Then what are the other loads? Can anyone say? So that's it for the dead load. Dead load. The what about live load? So live load, as per the code, you can take that as per the code. Which code we are using for live load? Can anyone say? IS 875 part 2. Okay, then the load. So this is as per IS
875 part 2.
875 part
Part 2,
3. For wind load, it is part 3.
1987.
So these are the loads that you have to select. So we'll assume the sheaf floating as 1 kilonewton per meter square, and we'll apply to the order. Go to loads and definitions. Go to loads and definitions, click on load case details, go to add, go to primary load case and give dead load. You can write it as dead load, click on add. Then we have live load, click on live load. Then we have wind load. Wind load will be in two directions. So wind load X, and then wind load Z. Okay, these are the two loads that are there. So these are the load cases. In these load cases, you can give the loading. So first I'm going to select the dead load, click on add, and here I'm going to add the self weight. Then I'm going to add the roof sheeting as a floor load, and give as -2 kilonewton or 1.5 as the floor load by range of 5, 0 to 5. Click on add and close. So this is the floor load that has been assigned, and the self weight is asking a question mark. Select all the members and click on assign to the selected members and click on assign. Okay, so these are the dead loads, and live load I'm going to take it as the floor load. But before that, I'm here the floor load is not able to, actually the floor is not properly assigned, because you can see over here it is assigned on the floor, it is not assigned on the inclined member. If you see, I'll explain it here. If this is my roof like this is my roof, the load is not acting on the roof. Uh, the load is not acting on the roof. The load is acting on this surface. Here it is getting assigned. In staad pro, it is getting assigned if I do it like that. So what I'll do is that I will create I'm going to create the uh, shed like this. I'm going to create the shed like this, and I'll create a plate over here and a slab level create chestnut. And for that, I'm going to assign the load. So this is not proper way of assigning the roof weight. So I'll delete this load, and then I'll go to the top view, and I'm going to go to the select these members like this on the roof, and for this one I have to select all the members, right? Here you have an option called Add 4-noded plate. Can you see that? Here you have an option called 4-noded
Yes,
plate.
sir. I can see, sir.
So that option you can use. Go to that 4-noded plate and click on the node first, second, third, and fourth. Right? This is the plate. So like this, first, second, third, and fourth. So automatically it will be created. First, second, fourth. First, second, third, and fourth. You can also see in the rendering view, that is this view. This is my rendering view. So you can also see over there, and you can, if you click over there like this, it is going to show, right? Like this, it is going to show. So for this, if I continue adding and add it like this, first, second, third, I think I have to add it in one day. Always follow one direction only. That is better. 1, 2, 3, 4. 1, 2, 3, 4. 3, 4. 1, 2, 3. So half part I have given. So we'll see how it is going to look if I, yeah, like this. It is going to come. So this, we can continue on the remaining part. Carefully, you should select the nodes. This is the wrong pick. So I'm just not going to assign it up there. Go back and click over here, 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 and here. Again, I have picked wrong node over here. So I have to go back again. Correctly on the node, you have to click, otherwise it will not come exactly on the location. So this is how I have to create the plates. Now, if you see the full 3D render view, it is going to look like this. Can you see it?
Yes, sir.
Right. So this is the model that we have created. For this, now you can assign the loads. Right. For that plate, you can assign the loads. Go to the general loads and definition. Go to the dead load. Go to the add load. And here you have plate loads. You have an option called plate load.
Plate load.
This one. Right. You can use that one. Simply clicking on this plate loads. And what is the load? Like minus 1 kilonewton per meter square, and it is in global y direction. Select global y direction and click on add and close. Now you can select this plate. You can select the load. Select all the plates. You have to select all the plates. So how to select the plates? You have a plate cursor over here. You have a plate cursor over here. This one. This is the one. You have to select
Sir.
that plate cursor. So if I select the plate cursor like this, it will be highlighted. Using control, you can select all the plates. By selecting control like this, you can select all the plates and click on assign to the plates and say yes. Now the loads have been assigned properly. Before it was not proper because the floor load will not take for the inclined members. Now we don't have, if we have inclined members, you can create the plates over there and you can assign them. But for plate also, if I click over here and see the 3D render view, there is some thickness for this plate, right? So that means we have to give the properties for this plate also. So then go to the general, go to properties, and there is an option called thickness over here.
Yes,
Can you
sir.
see? So
Yes, sir.
go to the thickness option, and it is asking the thickness of the plate. So what is the thickness of the plate? Generally, it is going to be for sheeting very thin thickness will be there. So it will be
Zero.
around 5 mm. It's going to be 5 mm. So 5 mm by 1000. So it is going to be 0.005.
205 maybe.
5 mm, 5.5 mm will be there. If you divide it by 1000, 0.0055. Or you can keep 0.006. Okay. And the material type, you can select it as steel or stainless steel. You can select stainless steel or aluminum or concrete. It is not concrete, it is going to be stainless steel. Select that stainless steel and say OK, right, and close. Now this you can select the all the plates and click on assign and and see that. Now this plate is going to, if you see the plate now, it will have a small thickness which you cannot see it, but there is some thickness over here, right?
Yes, sir.
Right. So this is the plate thickness. So this is my model. Now if I click on the whole structure, you can see that. And if you see the 3D rendered view, this is how it is going to look. So I've given eye sections over here, pole sections. I've used different sections. I've used for purlins. I've used eye section, circular sections. You can use any sections. You can change your section if they are failing, and you can again update the sections. So this is about the planning, and I'm going to stop here for today. So this is only the geometry part.